Universitas Insancita Indonesia, or UICI, was born as the first digital campus in Indonesia, which offers a system that is accessible for everyone. Accessible for everyone means that there is absolutely no limitation to receiving education. Anyone can go to college from anywhere, in any time, with no regard for space, distance, time, or even citizenship. With this educational concept, UICI has become the first campus to implement the use of artificial intelligence for education in Indonesia, and the fifth in the world. Artificial Intelligence Digital Simulator Teaching Learning System, or AIDSTLS, developed by UICI, is proven effective to become a flexible learning platform. This is not a web-based system. AIDSTLS can be accessed with or without any internet connection, with or without any synchronization with lecturers. Students also allowed to complete their course sooner, depending on their own independence, perseverance, and seriousness in understanding the prepared materials and assignments. As a campus founded by the Alumni Corps of the Muslim Students Association, or KAHMI, which certainly has a strong network.
Saya menyambut baik inisiatif KAHMI untuk mendirikan Universitas Insancita Indonesia, UICI, lembaga pendidikan yang dirancang berbasis digital dengan program studi yang inovatif seperti program studi sains data, bisnis digital. Ini akan memperkaya inovasi pendidikan tinggi kita. Inovasi-inovasi seperti ini yang harus banyak dilakukan agar kita mampu memenangkan kompetisi global yang semakin ketat dan semakin sengit.
Supported by the Indonesian government and more than 3,000 professors and academics from KAHMI, just in the third year, UICI has been able to reach more than 1,500 students spread over 450 cities and districts throughout Indonesia and in several other countries, such as Taiwan, Germany, Saudi Arabia, the UK, and many more. UICI's commitment to providing education for everyone is also complemented by various language options in AIDSTLS. The multi-language service allows AIDSTLS to be used by anyone all over the world, including countries that are members of the Organization of Islamic Cooperation, or OIC. And as an Islamic-based university, which is relevant in responding to the challenges of the time, where technology must be used as much as possible for the benefit of everyone. So what will be continued to be developed in the future? In a technological innovation, the endless support for digital advancement and R&D are important. UICI will continue to grow and become a pioneer in digital-based higher education with an Islamic spirit. For that purpose, let us be united in building a digital civilization through higher education. Together with Universitas Insancita Indonesia.
Together with University Insancita Indonesia, the last we have the scenes about the overview of the University Insancita Indonesia, and for the next we will have the welcome speech from the Vice Chancellor of Jasmar Koto, and to opening about the events or the webinar with them, knowing the development of artificial intelligence and machine learning in various sectors. For Prof. Jaswar, time is yours.
Bismillahirrahmanirrahim. Nahmadu wa ala rasulil karim amma ba'du. Assalamualaikum warahmatullahi wabarakatuh. And good morning for everyone here. or maybe good afternoon in the Arabia and also in Pakistan. For Pakistan is about maybe too early morning. Firstly, that I'd like to say to glorify Allah subhanahu wa ta'ala by His mercy, then we gather here, and by His hidayah that we can be Islam, and also that we also salawat for our Rasulullah sallallahu alaihi wasallam. Allahumma salli ala sayyidina Muhammad wa ala ali sayyidina Muhammad. Firstly, that I'd like to thanks to our rector our rector is here is Professor Laude Kamaluddin, Masihu Kamaluddin, to attend our webinar, and also that I'd like to honorable our speakers for my very close friend, long friend, Prof. Ali Slamet from UTM. Welcome, Prof. Ali, in UICI. And also I'd like to welcome to the Professor Dr. Muhammad Usman Asraf from the Women University Pakistan. Assalamualaikum, brothers.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Welcome to UICI for this morning.
Jazakallah khair. Thank you very much.
Jazakallah. Assalamualaikum. And also I would like to thanks to our honorable speaker, the Dr. Emil Hamda Imran from King Fahd University of Petroleum and Mineral. Assalamualaikum, brothers.
Waalaikumsalam warahmatullah.
Waalaikumsalam.
Yeah.
And also for the last speaker, that Professor Safi'i Samaun from King Abdulaziz University, Saudi Arabia. Waalaikumsalam, Professor Safi'i. Or maybe he's not joining yet. Okay, maybe he will join later. And also I'd like to thanks for our moderator, Mr. Aisa, and also for our Professor Dr. Satria that who organized, and also for the Dr. Iwan that already arranged for this meeting. Our topic today is the development of artificial intelligence and machine learning in various sectors. Maybe that in this seminar, there is a question why we rise up this topic, because currently in the world, in education, we are sick of the AI, especially ChatGPT. There is a pro and contra around the ones. Some is pro and some is contra. That there is one university, a couple university, they said not allowed to use ChatGPT by their student. But UICI currently is different. We allow it our student to use AI, artificial intelligence. Why? Because UICI is also use AI for education system. So therefore, that we try to use AI by AI, let them fight each other. So today exactly that we want to rise up how AI can implement it, and also look at from many angles, join with the machine learning from peripheral sectors. This is the reason that the main point that why we raise up this key of issue. And also that I'd like to thanks for our Vice Rector, Ibu Leli Plitasari, and also with others, our students, our members, and participants for this gathering meeting, gathering webinar. To not more speech that I'd like to open with Bismillahirrahmanirrahim. Let we open our seminar that because 9:30 already. I think we try to be on time for this one. I believe that our speaker, they are busy each other. They have another activities that like with Bismillahirrahmanirrahim, with mercy Allah subhanahu wa ta'ala, let we open together. Assalamualaikum warahmatullahi wabarakatuh. Time I will give to Siti Aisyah.
Thank you, Prof, for your speech. And for the next, we will thank you. And maybe you can give the statement to open this seminar, please, Prof.
Okay, so for this speech that I like to give a speech for this one. Again, that I like to, with the mercy of Allah subhanahu wa ta'ala, with the Bismillahirrahmanirrahim. The webinar we open. Then let's, inshallah, that for our attendance, I hope that we can be sharing knowledge from us. I believe that our honest speakers, they are expert for their own, knowledge on this part. I think this is all for me. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Alhamdulillah, we have opened the seminar UICI with them the development of artificial intelligence and machine learning in various sectors. And for leading the speakers, I will also for help Mr. Satria to lead and organize the speakers. Please, Mr. Satria, time is yours.
All right, thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Good morning. Thank you very much to all of you all. The Honorable, our guest speaker for today, Professor Ali Slamet, and the second speaker is Dr. Usman from DC Women University from Pakistan. And the third speaker is Dr. Hamdan Imran from the King Fahd University, Petroleum and Mineral from Saudi Arabia. And the last speaker from the King Abdulaziz University, Professor Shafi'i. So for the first sessions, there are two speakers, yani Professor Ali Slamet and Professor Usman. So before the Professor Ali Slamet giving his lecture, I would like to introduce and show the CV. Actually, let me share his CV. All right. Yeah. Honorable Professor Ali Slamet, he is currently the Dean of Malaysia-Japan International Institute of Technology, University of Technology Malaysia. And, you know, as I mentioned here, Professor Ali Slamet has received BSc from Teesside University from UK and the Master of Science also from Lancaster University, UK, 1997, and he got the PhD in 1998 in Osaka Prefecture University from Japan in 2003, and he was a principal consultant of Big Data Analytics, Minister of Higher Education in Malaysia, and a member of Malaysia of Artificial Intelligence Roadmaps, and he became a keynote speaker in many international conferences, and he was a visiting professor from various universities like Kuwait University in Japan, Kingdom of Saudi Arabia, including Indonesia, and currently he is the visiting professor at the Hradec Krylov University from Czech Republic and Kagoshima Institute of Technology in Japan. Okay. I will give the time for Ali Slamet. Before he starts, I will say hello. How are you doing, Professor Ali Slamet? Assalamualaikum.
Waalaikumsalam. Yeah, thank you very much for introducing me.
Yeah, thank you very much for joining. So I would like to give you the time for giving your talk. The time is yours. Thank you.
Okay. Thank you very much, the moderator, yeah, Pak Satria Anthony, yeah, and I think the director, yeah, and then the vice rector, yeah, and all the participants. So allow me to share my slide of the sharing this morning, yeah. Let me share the PowerPoint, yeah. Share the PowerPoint, and then. Can you see the slide?
Yeah, it's clearly.
Okay. So I'm going to share just allow me that I think I have about 25 minutes. Yeah. So I'm going to share the title today is related to artificial intelligence usage for fog-based intrusion detection. So a bit different compared to the title that I have sharing previously, but still under the areas of artificial intelligence. But today I'm going to share a bit on things related to the so-called intrusion detection. Yeah. So, well, I think let me try to play this. Yeah. 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 So, so again, thank you very much for inviting me to share on this topic. That this is the topic that I work together with other researchers, and I think my background already been shared by Pak Anthony just now. So I think I'm not going to share with detail of it. Anyhow, thank you again for inviting me. I think this is the second session, and this is my collaborator that we pairing this work. Yeah, from Iraq, from Addis University, UNIZA, and from Harare Kralove, my colleagues. Yeah, because I'm the visiting professor at the those university. So this is the outline. So I'm going to talk a bit on the areas of the research, then some literature, some methodology, some result, and some discussion. Yeah. So just a background. So as you can see, artificial intelligence, I think as mentioned by Prof. Jaswar, yeah, mentioning about the ChatGPT and others. So I think it's becoming very crucial to everyone nowadays. Yeah. And of course, apart from this kind of natural language processing being used for improving the readability of the text, yeah, we also can apply using this artificial intelligence in other areas as well. But I think the brain of artificial intelligence is machine learning, yeah. So this is very important element that is actually being held. I think in this regard, the economical scale of business is quite large, yeah. As you can see, it's about 15.7 trillion by 2030. And of course, job, yeah, automated AI, ChatGPT is like a disruptive. Now, like Google is also introducing their version of ChatGPT as well. And of course, how to make use of these brain computer interfaces, yeah. So it's becoming another challenge of this, because we have this cyber physical system, CPS, cyber physical system, and the other thing is related to how the industrial revolution utilizing the artificial intelligence to make things to work and reducing the dependency on the traditional jobs and things like that, yeah. And as you can see here, this is the areas that is related to artificial intelligence in computer and network security. As you can see, this is like the detection rate of the network security, because I think people nowadays using computers, either you are using your PDA and you are using your smartphone and others. So I think the security problem is always there. Yeah. So there are some methods that can be utilized, like deep learning. Yeah. And of course, fuzzy clustering is the other techniques that you can use. I think this is part of the artificial intelligence. All right. Then, as you can see here, this is the overall picture. As you can see in the computer network security, there are computer viruses, physical security, yeah, and theft and things like that, and system vulnerability, the penetration, and of course, the attack. So this is the computer networks security issues, yeah. And as you can see here, this AI, artificial intelligence capabilities, yeah. And you can see that this is the more important thing that you need to understand, that it's not just only the technology underlying the artificial intelligence. When we talk about the so-called artificial intelligence related to the computer security. So this is very big areas as well, whereby it's involving many areas like social engineering, impersonalization. You're using Facebook, using Twitters, and someone is using the ransom, and you call it smear phishing, and of course tracking. Yeah. So this is like the things that is happening, and of course the other area is related to campaign planning, malware. Yeah. So you have the campaign, the what you call as in your Facebook, you are getting some promotion, yeah, and of course backdoors, yeah, in your smartphone is there kind of tools to detect the movement of each of the individual person, and of course your cameras, although it's off, probably is on, so you don't know, yeah. So that's why I think its underlying securities is already existed there, yeah. And of course the attack adaptation and attack coordination steps, yeah. So this is very high level, yeah, on the evading detection and evading email filter is there, but we don't see it. I think the stealth is the most dangerous one, that it will go and penetrate your email box and things like that. And of course others are related to this the model theft of spying, yeah. So these are the level like recon sciences, and then resource development, initial access, execution, credential, and others, yeah. So these are the level of how the level of threat is existing, yeah. And this is the classification of artificial intelligence-based intrusion detection system. As you can see here, this is machine learning, yeah, and of course deep learning. So people nowadays talking a lot on deep learning, but in the old days, not very old, but I think these are the areas that people use very much on machine learning. That underlying principle is you must understand on mathematical formulation and of course the software engineering part of it. And you have the supervised intrusion detection using linear regression, support vector machine, SVM, decision trees, and unsupervised intrusion detection system. You may use k-means, you may use ensemble combination of different types of machine learning like principal component analysis, PCA, convolutional neural network, CNN, and of course recurrent neural network, yeah, and LSTM and autoencoder. So these are actually part of the deep learning intrusion detection system, yeah. And as you can see here, this is the analysis of the accuracy performance of machine learning versus deep learning algorithm. You can see that this is the different types of algorithm that we use. And as you can see, this is like support vector machine, k-nearest, particle swarm, naive Bayesian, and many others. And of course, this is the deep learning. So CNN, convolutional neural network, yeah. So this is rather, yeah, it's rather quite similar, but the percentage of the detection accuracy, yeah. And as you can see, this is like with the assemble, yeah. Assemble is like combination of different types of model like SVM and LM, yeah, RDT and others. So these are the model of the assemble, yeah. And as you can see that the accuracy is nearly 100% in this case of different algorithms. So that is one of the things that you may want to look at in a later stage, yeah. And what is fog computing? Yeah, fog basically, as you can see here, so this is normal PC. Yeah, you have the sensors connected to the PC, and of course you have the cloud computing over there. But if it is a small device, then you need to use a fog, yeah, because it will do the operational at a very small scale, but it can be done locally, yeah. So this is like home getaway, and this is like the fog is like in the middle. The processing is done partially at this locality rather than at the cloud, yeah. So this is what does it mean by what we call as fog computing. And as you can see here, this is the cloud, and within the fog itself, you can see that there is a fog node and the edge computing, and at this cloud level is heavily computation is there, but maybe taking a long time to have the decision be done. That's why some part of the decision to be done at the local level. So this is what we call as at the cloudlet access point. So it can be done here. And of course, this is the level where actually like the, like nowadays people have this autonomous vehicle or yachts, for instance, or drone. Yeah. So those decisions either to move forward, backward, need to be done locally. So this is what actually how the fogs work. And of course, someone may penetrate this signal sent to this particular what they call as appliances. Yeah. So this is the challenge of this kind of research. But again, that's very interesting element. And I would say that this is the current problem that we also may want to look at. Like the current ransomware attack spread quickly without a medium, and there is important target file and database in the fork devices. Yeah, so the fork is there, as you can see just now, but the targeted of the file is there, and how actually we can work to detect it. And there is no security tool on ransomware attack related to the fork Internet of Medical Things. So we are focusing very much on the Internet of Medical Things, and of course the problem is something that we need to look at, and how to design the IoT fork devices to be lightweight and easy, and of course to able to detect the kind of attacks, yeah, in terms of ransomware and things like that. So we propose the kind of sampling and resampling techniques for the imbalance issue. And as you can see here, this is Internet of Medical Things. That's appliances that related to medical healthcare. And of course, it can be like a wireless body sensor network, internet connected access point, cloud and big data service. And the problem with that is lack of security measures, and they are weak against the cyber attack. So this is the challenge, yeah, you can see. And as you can see, this is the general framework of Internet of Medical Things. So you can see that clinical experts from the government sector, researchers, the public, they are the stakeholders. And the healthcare data. So you can gather the data from medical images, textual data, laboratory sensor data, and there are technologies available like your Fitbit, yeah, or Fitbit watch, yeah, your smartphone, iPhone, and others. You can detect your heart movement and things like that, and others, the wristwatch and others, yeah. And I think these are the technology. As you can see, this is like the sample that cancer disease, for instance. So this is another symptom of cancers like fatigue, weight loss, skin changes, fever, bleeding, yeah, and how actually this can be detected at the early stage, yeah. So I think this is very important, whereby we need to develop model using artificial intelligence at this side. You can see, and this is the data. What are data that you need to capture, and then from there will be some explanation, yeah, on the issues related to the skin cancers. And of course, you need to have some decision from the expert to support the process and to validate it. And in terms of the wearable device mounted on different parts of the body, so you can see here like accelerometer, yeah, electrocardiogram diagram, electrophoregraph diagram, and location GPS, oximeter, and thermometer. So those are the things that you can see, that like camera clips, smartwatch, sensor embedded in your clothing to detect your body thermal condition, and of course your heart pacemaker, yeah, sociometric badges, and of course headbands, yeah. So these are very interesting, yeah, for us to look at. And these are the common AI techniques or application in Internet of Medical Things. You can see here. So these are the things that I use for diagnosis, for treatment, for management of the cases, and for the study. And you can see that either it's regression, segmentation, classification, health monitoring. These are the process related diagnosis. And for the treatment, you can see that remote robots, artificial agents, and others. Yeah. So these are the common thing used in diagnosis, treatment, management, and of course the studies of different symptoms of the patient. And this is one other example that IOMT, Internet of Medical Thing, in action. And you can see this this is patient lying on the beds. So we can have this remote health monitoring, yeah, on the heart status, and a hospital space, drug tracking. So which kind of drug being taken by the patient and things like that, yeah. So these are the simple part of it, yeah. And as the problem that we work on, so the fault detection is very important because of the emergence of fault computing system, and it's becoming a target by the multi-cyber attack. Yeah, and of course, it needs a geolocation response as fast as possible, and it holds very important data for the patient. Yeah, so if the data is being modified, then the result of the diagnosis will be differently, and different what they call as cure will be given, and different drugs. So it's becoming critical, and of course, critical attacks on the patient data set or patient data is also very crucial. Yeah, and I think this is the problem. that look at on this. I think I will just focus on one: lack of lightweight and accurate assemble detection method, which cause the layers between each or to fork. So I think I just propose or explain about number one on this what it calls the presentation due to the time limitation. Yeah, and of course some literatures. So I can see this is just literature review. We understand it from the literature and from the what is on the ground. We talk also to the medical expert, and of course people use the what you call as the facilities in the hospital. And I think the most gaps that we found that ransomware is critical is there, and if we are not taking care of it, definitely everyone is exposed with this problem. And some of the literatures that you can see on the machine learning point of view were actually being used, and a bit detail of this. And what you call a source of data being taken up, like Raspberry Pi, virtual machine, single computer, connected computers, connected networks. So those are the areas where actually the penetration coming in. And of course, the techniques being used like Keras, like Apache, Java, Amazon being used for the programming. And of course, these are some sample of data related to fog computing, how many they are, were actually being used, BOT, IoT, botnet, and SWOT, Tonto. So those are the data set related to the penetration of the ransomware. And these are the research areas that being taken care of. So you can see that this is the review studies. So techniques used like issue related to password phishing, poisoning and sniffing, reconnaissance, replay, scan, and these are the areas. And of course, involving the hybridization of the attacks, how big they are. You can see that network intrusion is the biggest one. So people connect to the network. The moment you connect to your device to the network, definitely there are someone that's sniffing your device. So it's not safe. That's why I think this is the challenge to not just only the IOMT, but also to everyone as well. And I think the most critical part of the gaps is that we can look this very important what you call as a situation that need us to look at the complexity, the attack, the risk, and of course the imbalance of the data and others. And these are the model that we develop on each of the phases, how we analyze the data, and of course we do some kind of analysis, either it's attack or non-attacks, and then we develop a kind of solution that involve with this. So you can read the end of this presentation. There is a paper, very detailed about it, but I'm not going to explain in detail how it works. And of course, you see here, this is the data that we use, either malicious or non-malicious. So this is the variation of it. About 70,000. And this is IDS about 128,000. Normal, malicious, and 97,000 malicious. And we can have this USNW also. So different types of data, like the injection, the scanning, the backdoor, the password penetration, key logging, and malicious control, and denial attack, denial service, and many others. So those are the things that we have. And of course, these are the class of the ransomware. You can see here, this is the collection of data set. So there is a WannaCry, PowerGhost, Petya, and others. So this is the proposed model, lightweight attack classification using fuse weighted features selection and weighted hoarding tree ensemble knife Bayesian network. So these are the model that we adopted using the fuse weighted feature selection and weighted hoarding tree ensemble knife Bayesian, and with different data set that we develop in this research, that we try to detect it on understanding how much the percentage of the detection or the attacks coming in. And just a bit explanation, I'm going to explain the detail, but the weighted hoarding tree assemble knife basis could yield different results, as you can see here on what you call the time, the classifier train and valid data set before and after the processing. So this is time taken and different data set being used for the classification. So the time is about 187 seconds to 70 seconds. We reduce the time, and the hours is from 257 seconds. And I think this is the reduction to 67 seconds from different data set that we use. So that's the results on incremental batch. So different analysis of backdoor, DOS, denial of service, exploit, fuzzers, normal, shellcode, worms, and generic. So these are the discriminative features. And of course, these are the results of the analysis of the techniques that we use on this experiment. So I think in a conclusion, as you can see, this is what we do. We develop the live assemble technique, and this is for the classification using different model like FWS and WHTN. So you can read more detail about this. And of course, this is the activities that we have to look at, and this can be used for the smart cities, yeah, and of course fog here, and of course low computational complexity because we develop it locally, and of course it's saving time and privacy preserving, and of course the technology that we look at is for security that can be used in any parts of the what they call as infrastructure, and of course we also look at the Society 5.0 on the societal development or SDG, yeah, and of course some publication that I would like just to want to share. You can read it from the publication on this what we call as papers, yeah. A bit detail you can see from this, yeah. So everything is here, and again I hope that you get some ideas of what I've been trying to share in this presentation. About the what you call as the application of what you call as machine learning, yeah, or AI for the what you call as fog detection, and this is related to intrusion detection. And of course, I hope that everyone just get some ideas on the issues of AI can be used in this direction as well, and definitely is a bigger concern from people across the globe in adopting a solution that is applicable to everyone. Again, I hope that I'm still on time. Yeah. Thank you very much for giving me the opportunity to share the research that we have been working on.
Yeah, thank you very much, Professor Ali Slamet, who explained to us about the usage of the artificial intelligence for VOG-based intrusion detections. So I think now many questions we start from the Q&A sessions. If anyone would like to ask the professor, you can raise your hand, or you can write down in the here. Okay. Anyone who want to ask the questions? It's a very interesting topic. No worry if you can type it here in the chat room. Any questions from all of you guys?
I think there is questions in the chat box, Mr.
The chat box.
Yes.
Yeah. Okay, let me read the questions from the Komang from Wellington, I think from New Zealand. What are the difference between AI in the medical fields and AI in the business world? Is it separate or dedicated cloud required? This is the questions from the one of the participants. You can answer.
Okay, thank you for the question. Yeah, I think related to the difference of AI in the medical field and AI in the business world. I think, yeah, so AI in the business world, usually you heavily using the cloud directly, yeah, whereby you need to have a big data to be stored over there. But you don't need, like a banking system, you don't need fog computing instantaneously to work with you in your place, yeah. But in a medical field, you need AI to be specifically embedded in each of the appliances, yeah. When you are embedded, so the machine that is not just a machine, but the surrounding environment, the room itself, the temperature, the humidity, and of course the what they call as the drug prescription, and your body temperature and your physiology. So those has to be sensed by different devices, and those devices need to have some kind of mechanism to alert the central processors to make it we call it fast decision making to be done. That's what I've said. AI in medical is very crucial because it's involved many data to be used within the physical locality of the patient himself in the room that being warded. Yeah. So in the business world, usually we use a cloud computing. So the cloud can be somewhere, not within your locality. Meaning it's not in your building. The cloud is somewhere in Jakarta or in Bali or in other places, but you can still make a decision from the data. Yeah. So I hope that the question is being answered based on this explanation.
Yeah, thank you for the comment. I think it's clearly answer your questions about the difference AI and medical field and business field. All right, someone already raised hand, Mr. Faik Bahfend. Yes, you can.
Okay, thank you.
Yes.
Assalamualaikum.
Waalaikumsalam.
Thank you for Professor Ali. For medical health, for medical field, I have some problems. I want to ask you how to solve problems related to making diagnosis for patients related, for example, computational tools, color resolution, and how about licensing issues? Because every country is different for licensing issues for health workers who can practice globally. Please enlighten for me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you. How to solve the problems in license? You can, Professor Ali Slamat, you can directly answer the questions.
Okay, I think the issues of the licensing and using the probably the technologies and of course the expertise. I think one is related to the field of expertise of the expert in medical as well. So each country has a different regulation, so that has to be passed within the country's regulatory bodies as well. So like in Malaysia, we have a SIRIM, for instance, but they still need to work together with the Ministry of Health to get a clearance and I think ethical clearance before any research or any implementation of the process can be done accordingly. So I think that's one element. And in terms of AI as well, when you are becoming like a developer of the solution of AI, for instance, so it has also pass the ethical clearance, because when it's involved human in nature, especially in medical areas, you cannot just simply test it like you test the animal as well. So that's very crucial, and it's not simple process. So a lot of not a lot of checking need to be done, and a lot of consultation need to be done as well. So this is the challenge when you introduce a new solution. That's why in Malaysia we work together with the research institute, yeah, and then with the medical expert that working in the medical institute as well. So that's very much important. So we have to work with them so that they know well about this problem, and they know also what is the solution that we propose. Therefore, it's not infringing the what you call as the jurisdiction, yeah, of the rule and regulation stipulated within the what you call medical what you call as field. So I think that's very much important that we have to look at it very much. Yeah. All right. So I hope that answered the question. Again, any other question? Yeah.
Thank you, Prof. Ali.
Yes, you're welcome. We cannot hear from you. Yeah, Pak Anthony.
All right. I'm sorry. This is mute. All right, for the next session is for awarding certificate to the Professor Ali Slamet as the keynote speaker. I think Miss Intan or protestation. What do you think? First is the giving the certificate award to the keynote speaker, and then we take a photo session after this. Which okay. Yeah, this is the. Could you see the certificate? Yeah. Hello.
Yeah, thank you for the certificate.
Yeah, we highly appreciate Prof. Ali Slamet, the Dean of the University of Technology Malaysia, UTM. So we would like to give this certificate to you as the keynote speaker. So this is the honor from our president of university, Professor Laude Kamaluddin. So thank you very much for your time, for coming and sharing your knowledge. It's very important topic and very useful for our student and for the future. Thank you so much, Professor.
Mr. Satria, maybe there is the short speech from the rector to give the certificate, maybe.
All right, yeah, for sure, yeah. You mean Professor Laude? You mean Professor Laude is joining with us?
Yeah, he has joined already.
We call Professor Laude to give the certificate award, the keynote speaker, to the Professor Ali Slamet. I think he's still mute. Please tell him he's still mute. Miss Intan, you can come up with the Professor Laude. I think he's still mute. Okay. Hello, Miss Aisha, do you hear me?
Yeah, I can hear you. Yeah,
But I think if he cannot
the
join,
processing will be.
it's still processing, or we can wait, or on behalf where we have Professor Jaswar. I think Professor Jaswar.
Yeah.
Yeah, I think there is a technical issue. Is the Prof. Laude is the president of UICI. So on behalf, can give the certificate to the Professor Ali Slamet. I think time is yours.
Bismillahirrahmanirrahim. On behalf of the UICI, for the president of the Professor Laude Masih Kamaluddin, I'd like to give the certificate to Prof. Ali Slamet for our guest, honorable guest for the speaker for today, our UICI seminar.
Alhamdulillah, this is the thank you so much.
Thank you, Professor. Thank you.
Yeah,
Thank you, Prof. Ali. Thank you.
Yes.
Yeah. There is also thank you, Mr. Ali. There is a question: is there any certificate for participants? Yes. We already prepared the certificate for the participants. Thank you, Prof. Ali. I know you are busy at the moment, so we highly appreciate for your time to join with us, to share your knowledge to our students and our university. Thank you so much.
Thank you very much to everyone.
Yeah, thank you.
Thank you. Yeah.
All right, for the next session is the second keynote speaker from the GC Women University from Pakistan, Dr. Osman Ashraf. He is the associate professor in the UICI Women University, Pakistan. Before he give the talk, I would like to introduce in his CV. Let me share his CV. Wait a moment. Yeah. Yeah, this is Dr. Osman Ashraf. He's from Sialkot, Pakistan. He's actually did PhD in computer science. He's my colleague. It was my colleague. We stayed together in King Abdulaziz University in Jeddah from 2015 2018. And also he did master science in computer science in the University of Lahore. And he did the second MS, Master of Science in the University of Agriculture, also in computer science. And he did the Bachelor of Science in the computer science and mathematics in the College Satellite Town in Jamwala. Yeah, as a career summary, he is 13 years of experience in research and development and teachings, and he has more impact papers, and he won 15 research projects from national or international funding agency, and he is a hands-on industry experience in terms of software development. Well, I think I already mentioned here, this is the research interest. He's currently working in the high performance of computing toward exascale system, and also working in the parallel computing using MPI, OMP, UDA, OpenSCC, then etc. And recommended systems. Also, he receives various honor and awards as the best researcher of the 2021. And also he's the fully funded scholarship for international scholarship from Saudi Arabia, and he attends many conferences in all over the world, and he gets invited talks from other international conference, from many international conference all around the world. Yeah, he supervised many students. Currently, he is supervised for a PhD. Yeah, this is publication. He published very highly impact factor. So I would like to call Dr. Osman Ashraf to give a special talk to you for this morning. Welcome, Dr. Osman. Assalamualaikum. How are you doing?
Walaikum assalam wa rahmatullahi wa barakatuh. Yes, alhamdulillah, fine. Thank you very much. First of all, I would like to say thank you very much for all the excellencies, the organizers, for arranging this prestigious conference. I hope you can receive my voice and video clearly. Before starting, I want to make sure that my voice is clear. Is it okay, Professor Dr. Satria?
Yeah, it is clear enough. Go ahead.
Okay. Yeah. Then I think it's better if I can stop my video, because with live streaming, maybe sometime there is internet connectivity issue. So it's enough to show myself in live for a few seconds. Then now let me start my presentation.
Okay.
So my presentation is visible, Dr. Satria?
Clear.
All right. Bismillah ar-Rahman ar-Rahim. Thank you very much, Professor Dr. Satria, for giving the nice introduction. Yes, my name is Dr. Osman Ashraf, and I am also the chairperson of the Department of Computer Science, associate professor here. I would like to say thanks to all the participants, the excellencies, and the organizers for arranging this UICI webinar, the development of artificial intelligence and machine learning in various sectors. So for today, the topic of my presentation, my talk is about the roadmap toward the smart cities, in which we will discuss about the role of artificial intelligence, high performance computing, and Internet of Things. Why I have selected this topic, let me give you a brief overview before starting the formal presentation, because basically artificial intelligence, what I think is the technology that is applicable tool for in our daily life to make our daily life more and more easy and more convenient for our citizens. If we make our life more easy, better way, then artificial intelligence play a very well role. So the race over the world is to facilitate our end user, to facilitate our customers, to facilitate the human, how we can reduce the efforts from human, and we can engage our emerging technologies. So if I talk about the emerging technologies, then I must have to discuss about artificial intelligence, high performance computing, Internet of Things. So this is the reason I have selected this topic. And now let me move toward the formal presentation. I have arranged the outline in this way. First of all, I will describe briefly about the smart cities. What actually is the smart city? If we say any city to make it a smart, then what are the parameters that we need to introduce, we need to implement in that city? Then we can say, yes, this is the smart city. So this is very important to understand before moving toward the technologies. What is our actually target, where we want to apply these technologies? So before defining the objective, before defining the goals, it's, I think, useless to learn the technologies. Sometimes you don't have the goals, and or you start seeking the technologies, learning the technologies, but after that you think, oh no, I am at wrong way. I must have to define my goals. So based on your goals, you have to learn about the technologies, as Professor Dr. Ali described very beautifully in his presentation about all the aspects in which AI can be engaged. And I was listening the questions from the audience, and I would like to give a brief overview there that yes, we can engage AI in our business perspectives, in our medical domain, and even in our daily life, in every domain. But as I have said, firstly, you have to define your goal. What is your goal? In which domain you want to apply the AI or the different emerging technologies? Then based on your goals, based on your priorities, you choose the tools from AI. Then you start learning about the AI. So firstly, we will discuss about the smart cities, then the role of technology, how these technologies, emerging technologies, playing their role to make betterment, to bring the betterment in our smart cities, in our daily life. Then I will present an overview of AI-based framework for smart cities, which is actually a fundamental framework, and that can be considered and followed if anybody wants to join this domain. And he must understand this this framework before starting. And once he understands it, he can choose any particular area from this framework and can start working in this area. Well, regarding the smart cities, this is basically the concept in which if I say that this is the concept that see the adoption of data sharing smart technologies, like including computer technologies, including the Internet of Things and information communication technologies, to basically improve our energy efficiency, to minimize the greenhouse gas emissions, as most of the participants here from different domains. So that's why I will give the examples from the multidisciplines. So we can improve the quality of life of the city of the citizens. So if we see all these factors, then if we can say that, okay, smart city is already in among of us. So what is exactly the smart city? So when we talk about the smart city, we may think the concept like self-driving electrical cars, renewable energy mechanisms, image automated technology. So from a film like Minority Reports. So it is in fact not about the futuristics, but sometime more about the fundamental information collection, more information, the efficiency in the system, in our daily life, the more accuracy in our implementations, more accuracy in our systems, the privacy, the protections, security, and more smartness, how our context is reacting smartly when we are asking to deliver anything, to facilitate us in some way. So when we consider all these aspects, then we can say, yes, we are moving towards a smart city. So this is actually the primary look of smart city when we want to come in this this domain. If I talk about the top 10 smart cities over the world, then we can say everybody may know about all these countries. Singapore is the top one. They have implemented these defined parameters in their smart cities, and they declare the Singapore as a smart city. Then Switzerland, the Norway, same like the Finland, Taiwan, and different countries. So they have actually implemented all these technologies in order to achieve the smart city concept. Recently, there is another city from the South Korea, that is actually Songdo. I'm sorry if I am not pronouncing in the correct way. Its name is Songdo, and they have declared this city as the ubiquitous city. They renamed the city as the ubiquitous city. It means the full-fledged smart city, which is actually built on 600 acres of their land and 30 kilometers the southwest of the Seoul. So the concept of smart city is becoming more and more popular over the world, and the people are trying to facilitate their lives, the others, with the concept of this smart city. Now I will give some the parameters that must be the keywords that must be understood when we are talking about the smart city. The first one is the collaboration. Yes, there should be the great collaboration between the public sectors, the private sectors, the environment, to exchange their data, to share their projects, to make the convenient to share their services in more efficient way. Similarly, another save. Yes, when we are talking about the save, it means the smart city thinks in a sustainable way, and therefore we intend to save the energy, water, raw material, food, financial resources to continue the prosper of any area of transitions. So we have to bring the innovation And the smart city must encourage its citizen, its business and public services to come up with a new way of organization with innovations. So then we have to integrate the services that cannot, like the smart city, cannot leave anyone behind, and the must therefore enrich each person's quality of life. Participation, yes, so this is very important. The business perspective, citizens, and the projects. Everybody who wants to get facilitation from this environment, he should participate in this era, so that the smart city system can be built and simplify aspect of a few rare smart cities created from the scratch. All actually have a past duration, which regulation of customs have gradually developed. So they must consider all these 6 parameters that are the pioneer parameters considered when we talk about the smart city. So this was actually the initial these are initial attributes that should be considered. Now let me move toward the technologies, how our technologies are engaged when we are talking about the smart cities. And technologies, as I have discussed in my start of my presentation, that what is exactly your agenda, what is exactly your goal in which you want to apply the smart cities. So you want to apply your these technologies. In that case, we have actually major domains in smart city that can be seen on the screen, like smart governance. We want to achieve the smart governance in a smart city. We want to achieve smart economy, smart education system, healthcare system, a very smart environment that in which we can implement our the concept of Mark Weiser. If anybody is from computer science domain, they can understand what I am talking about. Mark Weiser view that was actually proposed years ago, and he, according to Mark Weiser, he actually gave the idea of ubiquitous computing. He said the environment should facilitate the human without interaction of the third parties, and they should be very smart enough, and we must have to hide our technologies. So there is no any other third party. There is the person, there is the context, the objects that are facilitating to the customer directly. So we are hiding our technologies. This is actually the idea of ubiquitous computing, same like smart living system and smart mobility system. So these all domains are categorized when we talk about the smart city. Now, what is the role of the domains that can play a major role to bring these areas the more with respect to the smart city, the more smartness in these areas? Yes, the first one that is very important and that is very emerging technology, that is AI, artificial intelligence. When we are making our things more intelligent, then we are calling about these things as smart things. Okay, so AI playing a major role. After that, ultimately, there is another technology, that is IoT, because you have to receive the data from all these domains. And in order to receive data very smartly, as I have discussed, hiding the technologies. When we are talking about the hiding the technologies and receiving the information, it means we are talking about the IoT technologies in a very smart way. Then another domain that is at broader way, that is high performance computing technologies. High performance computing technology is also playing a very vital role when we want to establish our systems in a smart way. and we want to apply the artificial intelligence in a very efficient way, it means we want to cater the research, want to get the services in very efficient way. So we, in that case, we are talking about the high performance computing. So these three technologies are playing a very major role in order to bring the smartness in our society, smartness in our cities, that should be emphasized by the research communities, research services. In next slide, if I see the categorization of AI technologies specifically, then we can say that artificial intelligence is considered as the umbrella. Sorry for that, I am not digging in about these technologies, because if anybody wants to learn about these technologies, he definitely must have to join the courses to understand in details. But here I will give a brief overview how these technologies are interacting in our daily life and interacting in smart cities in better way. So you definitely think yourself that which technology is appropriate in your domain, and you have to choose that technology. So in short, artificial intelligence is actually the umbrella, and under that umbrella there is the major, a very more popular technology which is being used in the machine learning. And under machine learning, we are using deep learning, predictive analytics, and similarly NLP, natural language processing. If you want to, before discussing NLP, let me give a more brief overview about the machine learning, ML. If you want to train your systems, if you want to predict something for the future and you want to apply the mechanisms of the technologies, then this machine learning model is the best model you can apply it. Now, if we want to move another way, that is the natural language processing, and we want to make the translations, you want to make the some exact information extracting and classification and clustering. You have a lot of knowledge and you want to extract the exact information from your available data, then you have to use the natural language processing. Another technology under the umbrella of artificial intelligence, that is speech recognition. This is very being common in over the world and being used. Speech to text and text to speech. The people don't want to waste their time and they just want to speech and get the text. I have seen in my institute, most of the students, they are using this technology. They are just talking, speaking something and receiving the text in the form of refined text, and they use that produce text for their research purpose instead of writing and making the traditional efforts. So they use this technology in a very better way. And similarly, vegans, yes, image recognition, that is also a very particular domain. And here, recommender system, that is actually not a new thing here. That is like recommender system, expert systems, and robotics. These all the technologies are playing a very well role when we are talking about the artificial intelligence, but yes, in different perspectives, in different domains. If I am saying that I have like a project about in business, then I must have to choose the machine learning, because that give me the predictions. I don't want to lose my my business, and I always want to win situation. So I should have a model that give me always the prediction in better way. So I have to choose the ML here. I can apply, but as I have said, we must have to understand firstly, before applying these technologies, we must have to understand what is the purpose of these technologies and how we can achieve achieve our goals by applying these technologies. So this was actually overall overview of artificial intelligence with respect to the different broader domains that can be used in our daily life. Further, we have to understand the concept of AI-based smart city technologies, as the topic is related to the smart city. So when we talk about the smart cities, there are different layers. The top one layer is the smart city. It means just under the smart city, we have different applications. That is called the application layer. And in application, in our societies, what we are doing, we are using the healthcare system, the agriculture system. We want to provide the privacy of our user. We want to secure his data. We want to bring the mobility. We want to localize our services and environments. We want to make the waste management systems to organize the system. So, okay, although we already are doing all these things in our society, then what is the new? How we can improve our system if we are already doing all these things in our daily life? Then definitely we have to use the technologies. And at broader term, as I have discussed previously, that is the processing layer, high performance computing based model, high performance computing based layer that process the things very efficiently, very fastly. But just process the things very fastly is not only the solution. We must have to consider another technologies. That is actually the artificial intelligence. And in artificial intelligence, I already have given a brief overview about these the subdomains, NLP and machine learning and deep learning. So I don't think so we need to go and digging in again. So in nutshell, yes, there is another technology that is artificial intelligence that actually will bring the smartness. Before the smartness, we were about bring the efficiency, yes, but the efficiency is not enough. So to making the things more smart, to making the things more intelligent is also a very major goal of our daily life, implementations. Then another thing is the storage. That is also a major challenge. Like everybody getting smartphone having in his hand, and he just whenever he want to capture the environment, the things, he just start capturing, and he never realized where this data is being stored and how much the volume is data is being stored. Nobody is caring about it, but yes, these are actually the technologies, and there are the solutions. And this domain is called actually the big data. So if there is a big data, we should be concerned about the storage of our information, that we are, like in current session, we are storing our information on the YouTube and different platforms. So in billion of the videos and images are being captured on daily life, on daily basis. So we must think about these parameters, that what should be the efficient way to make these storage efficiently, and when we are talking about our systems more intelligent, our system more efficient. So this is also the concern. The last one is IoT data collection. As I have discussed previously, IoT Internet of Things, that should be implemented in our systems, our daily life applications, when we are talking about this, to bring the smartness of our systems. Then IoT is playing actually the vital role, because we want to cater the data. We want to get the huge of data from our different parameters, different objects. So in that way, in order to get that data in a very smart way, Internet of Things providing beautifully all the services, and we can get data. So ultimately, if I summarize all this framework, when we are getting this data, and we must have to store it on our big data storage systems that can organize in better way and make data analysis, which data is more accurate and which data is more actually required that should be provided to the next layer to make the intelligence of the system. Then we provide that data to the artificial intelligence systems, then apply some algorithms from HPC systems to make the services more efficient and provide the services to the upper layer, application layer, which is actually our domain. And everybody can understand from here that if anybody is from a medical domain, he can understand, yes, you are here and you have to understand these all technologies. Then you can get the benefit of these technologies. Next, this is actually overall the utilization of AI. If I say the major domains in over the world, if you see from this image, actually AI have deployment in major smart cities domains like healthcare, mobility, transportation, privacy, security. So if from this figure, you can say that most of the interaction of AI technologies and even IoT technologies is in healthcare system, that is actually 23%. And similarly, to bring the mobility and transportation in better way, that is 19%. And yes, people always ask the IT expert, we want to protect ourselves. We want the protection, our data protection, ourselves, security. So we are working in the privacy and security as well. So we, that is actually, you can see that it's 11%, but now its ratio is becoming up and up again. Environment cleaning, waste management system. Currently, even we in our university with my students, my PhD students, they are working in smart waste management systems. So this is also becoming a very popular, because waste collection of waste is okay. We are collecting the waste in our traditional way, but managing the waste in very efficient way and smart way is very big challenge for these emerging technologies. How we can engage these technologies to make the smart waste management system. So that is actually another challenge. It doesn't mean that we are engaging the human effort again and again and we are saying, okay, this is a smart. No, actually we have to engage our technologies and making our systems more efficient. In that way, we can say that yes, now our systems are smart. So this is overall the overview of the implementation of artificial intelligence in daily life. If I conclude this presentation by a future perspective, then we must have to understand, okay, what is the demand to promote in our technologies. Then the first thing is regarding the HPC systems. Yes, HPC systems are not more efficient as per the demand of the user. Okay, so we must have to think about the co-design of the future HPC systems that are actually the exascale computing systems. So there is actually big race to achieve this exascale computing system, a very powerful exascale, mean 10 raised to the power 18 number of instructions can be calculated within 1 second. So you can imagine if we have 10 raised to the power 18 number of instructions and can be calculated within 1 second, how much powerful system that will be if we can achieve this system. And there is then no need, maybe at current stage, there is no need to worry about the HPC systems if we achieve exascale computing system. Yes, what are actually the issue to achieve this exascale computing system? There are two major challenges. One is the performance, how we can achieve the performance in exascale computing system or HPC systems. And we that is another story. We can use the parallel computing, the high in massive parallel computing systems. Then the second major challenge is the power consumption. the underdeveloping countries are the third world countries. Yes, they are actually facing this power consumption issue majorly because they don't have enough resources to consume their power. In like if let me give example, if a simple HPC system we talk about that, then it can consume more than 100 or plus megawatts. So 100 plus megawatt is very big amount of power. So we must have to think about it. This is another research domain. If any person want to find out the research area, then this is the better way to explore about it. Yes, the second thing is need to promote is artificial intelligence algorithms, ML, machine learning algorithms, NLP, deep learning, these skills. And in this way, previously, what was actually the concept? That was actually to implement these technologies directly and achieve the goals. But now the race is on another way. We have to along with the implementation, we have to achieve the accuracy. And currently, the accuracy is being improved day by day and being achieved. And target is definitely to achieve the 100%, along with the 100% efficiency. In very high efficiency, and I mean, using this can only be possible when we can achieve the HPC systems with the target goal exascale computing systems. And the last thing here is, yes, IoT frameworks. We have to improve the IoT. And when we talk about the IoT frameworks, then we must have to think about the cloud computing systems, cloud services for computing systems, and edge computing systems. These are actually separate domains. We cannot describe these domains within few minutes. But yes, when we have to apply IoT technologies in our systems, and we have to use the AI systems, ultimately you are supposed to use the IoT as well. Then in that case, you have to think about these computing system as well, because these computing systems are becoming more and more popular when we talk about the smartness in our daily life, in our societies. The last thing that is, I think that the more important, all above these parameters, is to be human, to make our earth neat and clean. Yes. If we are not responsible, if we are not thinking about it, then technologies can't do anything. We must have to think, we must have to be human, first of all. Then after that, we can bring all these prosperous systems in our daily life, our societies. And then, inshallah, everything will be fine with by the using of all these technologies. So it was all about my presentation. Thank you very much. Once again, thank you very much for all the organizers, the excellencies, all the participants. If anybody has the question, please raise. I am actually here in my house, and will leave for the university maybe after a few minutes. But no problem, inshallah, I am here to answer if there is any question.
All right, thank you so much, Dr. Osman Ashraf, for your interesting presentation for this morning. So this maybe I think more questions from the participants. You could raise your hand or write it down in the chat box. So please, anyone to answer? Anyone to have a questions, please? To Dr. Osman is talk about the interesting topic about toward the smart city and the role of AI and Internet of Things, and he divided into 7 AI in smart city as we listen of his presentation. So anyone has questions, participant, please raise your hand, or you could write in the chat box. Anyone has questions? Yeah, let me check the there is one question from Komang. I will try to read. Yeah, from the
Yeah, there is one
Yeah.
that I can read it, Professor Tia. The question is in the term of smart cities only applicable to the technology advanced urban area? What about the rural, remote, hilly, mountain? Yes, we also refer to them as smart city as well. This is very good question. Yes, first of all, the point is what is our goal? The goal is to implement these technologies. So where we can implement these technologies, first of all, we have to think about that. As the cities, the urban areas are more appropriate, the place, the environment, we can apply these technologies there in a better way. Once we achieve a good results, when we achieve our goals, then ultimately we can transfer these technologies to the rural areas, to the remote areas, hilly areas as well. But firstly, we have to define where these applications, these technologies are appropriately applicable in the environment. I hope I have given an answer.
Yeah, it's very clear answer from Dr. Osman. Anyone else?
Professor Faik, thank you very much for the appreciation. Jazakallah.
Yeah.
Good. Very important for me. Can I ask one question?
Please.
Yeah, sure.
Thank you. I want to know a relationship between healthcare data and secret and privacy data. Who is responsible if lacked information if lack data? Who is responsible? How to regulate it? Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Yeah. Answer.
Sorry, Dr. Faik, question is over. Actually, your voice is cutting. There is a distortion. So if you can repeat the question, please.
Okay.
Dr. Sattar, you can repeat the question, please.
Okay. Relationship for healthcare. Healthcare is one important for build a smart city. It is correct? Eh?
Yes, exactly.
How about the relationship about the healthcare data, every person, and the secrecy, privacy data? Who is responsible if something, for example, not good application of artificial intelligence, NLP, MI, then etc. Who is responsible to keep it? Thank you. Assalamualaikum.
Walaikum assalam warahmatullahi wabarakatuh. Very good question, Professor Faik. Actually, if I give the answer in very nutshell, that the artificial intelligence is not the solution for all the problems. Okay, we have to engage our existing technologies as well. Like our existing technologies from recently, I was working the same project, healthcare system, and we are actually developing early heart attack detection system, how we can detect the heart attack at the early stage. So definitely, as according to your question, there is the big concern about the data protection, privacy. So we are using the existing privacy protection algorithms like the cryptography, how we can encrypt our data, make protection for the user instead of disclosing his information. And then when we want to make efficiency, we want to predict for the future perspective. In that case, we are applying artificial intelligence. Okay, but definitely for the protection, we have to use existing technologies as well, existing algorithms. I hope I give the answer.
Yes, thank you very much, Professor Osman.
Yeah, thank you very much, Mr. Osman. Now it's time. I think time is up.
Oh, thank you very much to present here at
thank you.
this platform.
Highly appreciate.
Yeah, Jazakallah.
Yeah. Now is what is the awarding the certificate to Dr. Osman?
Yes, please.
Yeah, maybe Professor Jaswar. Just let me. Professor Jaswar, are you with us?
Yeah.
Yeah. Is the certificate. Yeah. Could you see the certificate?
Yeah, I can see now. Thank you. Maybe the pictures is Dr. Osman, I think.
Yeah.
Changing the, I mean the pictures supposed to be not used. Changing
This one.
yeah, the Osman, choose the Osman. Okay, thank you.
All right.
Okay. Bismillahirrahmanirrahim. On behalf of UICI, Professor Lode Masihu Kamaludin, Rector of UICI, Universitas Insan Cita Indonesia, I'd like to give the certificate to the Dr. Muhammad Usman as a honorable speaker for our webinar today.
Thank you very much. I have
Thank
received.
you very much.
Thank you very much. Jazakallah.
Thank you.
Great honor to receive the certificate from you. Thank you very much.
Thank you.
Jazakallah.
Thank you. Thank you.
Thank you.
Thank you.
Thank you, Dr. Usman. Highly appreciate for your time.
Thank you very much.
Yeah.
If you don't mind, may I quit the
Yeah,
link, the meeting,
sure.
because I have to reach my university.
All right, no problem. Yeah. Thank you so much. Keep in touch.
Thank you, everyone. Thank you. Jazakallah. Assalamu alaikum wa rahmatullahi wa barakatuh.
Walaikum salam wa rahmatullahi wa barakatuh.
All right, for the next sessions is the third speaker. Let me read speaker. Prof. Dr. Emil Hamda Imran from King Fahd University, Petroleum and Mineral from Saudi Arabia. Before he starts his talk, I would like to introduce, let me share his CV. Moment. Yeah, this is the biography of the Dr. Emil Hamda. Is currently working in the Applied Research Center for Metrology Standard and Testing Building in the University of Petroleum and Mineral, and he did a PhD in the electrical engineering from University of Newcastle, Australia, and he did master in the KFUPM, Saudi Arabia, and then he did Bachelor of Science in Electrical Engineering in Andalas University of Indonesia. Yeah, he currently working a postdoctoral fellow. Yeah, in the, as I mentioned, Applied Research Center for Metrology Standard and Testing Research Institute, and Then she also became a postdoctoral research associate in the Department of Engineering in Lancaster University, UK. Yeah. Also, became a researcher at the King Fahd Petroleum University Mineral. All right, let's give the time to Dr. Emil Hamda to start his presentations. Yeah, how are you? Yes. Dr. Emil, are you joining with us?
Yeah, thank you very much, Dr. Satria. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullah.
Alhamdulillah, wassalatu wassalamu ala rasulillah wa ala alihi wa sahbihi wa man wala. Yeah, I will start my presentation. Yeah, let me share my screen.
Yeah, you can start. Maximum 15 minutes, Dr.
Yeah.
Emil. Yeah.
Yeah. Today I will present the robotic from control theory to machine learning. So I am Emil Hamda Imran, affiliated with King Fahd University of Petroleum and Mineral, Saudi Arabia. And then I would like to express my gratitude to everyone, to the UICI, to give for the opportunity. And yeah, I can skip this page as Dr. Satria already introduced myself. And then I would like to start my presentation. First, I want to introduce what is robotic. Yeah, robotic is a multidisciplinary field that involves the design, construction, operation, application robot. And then one research interest that closely related to robotic is control system. This control system refer to the mechanism and algorithm to enable a robot to maintain the stability, achieve the desired behavior, for example, like to achieve the desired trajectory, to have the desired path planning, and also to execute a task with high accuracy and precision. Yeah. And then we know that application of a control system in the robotic we can find in the medical robotics, industrial automation, autopilot feature in aeroplane and manufacture, especially in medical robotics and autopilot. So high accuracy performance of the control system is required, as this related to the not only the it's related to the someone else. We know that a control system has quite a range of application in robotics. For example, for autonomous vehicle, and also in the medical robotics. In autonomous vehicle, control systems are used to ensure that the system is safe and then efficient in navigation. And also, industrial automation, for example, they use to optimize the production process and increase efficiency. The technical part is in the medical robotics that really heavily on rely heavily on the control system for precise and accurate movement during the surgical procedure. Yeah, and also in manufacture for the it is for the industrial automation. So there's so many applications about the control system in robotics. This is a mobile robot. So they have many typical of mobile robot. For example, like 3-wheel mobile robot, 4-wheel, 6-wheel. So many mobile robots. And mobile robot have the one behavior that difficult to be controlled because mobile robot is the non-holonomic, have the non-holonomic behavior. What is the meaning of non-holonomic behavior? The number of control input to maintain the movement of the mobile robot is less than the state of the mobile robot. It means that the proper controller is required to maintain the system. And also in mobile robot, it's contained that they have the nonlinear dynamics, and also may have the might interrupt by the external disturbances. And this under robot, this is a very famous one, unmanned aerial vehicle, UAV, or we know that as drone. We know that drone is advanced in mechatronic and microelectronic, and UAV have been used in many applications, in civil application, creative industry, surveillance, also like for the monitoring, data monitoring, photography, even also in military. So, and to implement a proper control in UAV is very important. And like the mobile robot, control design for UAV is much more complicated. As UAV have the 6 stages, XYZ is the XYZ axis, and then they have the roll pitch stage. And UAV only have the 4 control input to maintain the system. For the XYZ, they only have the thrust to maintain the system, and then for the roll pitch, they have 3 to maintain that. And what is the research challenge in controlling UAV is like mobile robots. So this UAV is very sensitive with the disturbance that we need to make sure that our controller is robust enough to maintain the system. And in the industrial application, so we know, this one robot manipulator have been used in many fields. For example, like in automotive application, or even like this figure. So this combination between the mobile robot and then tooling robot manipulator, robot manipulator. Not like the mobile robot and then UAV. Robot manipulator is the fully activated system that we can control each state using the one controller. And what is the key component of the control system? The first is sensor, and then actuator and controller. What is sensor? Sensor is, sorry. Sensor is a device that provides information about the robot environment and its states. For example, by using sensor, we can measure the velocity, position, orientation, distance, for example, or also we can measure, for example, like current and voltage. It's depends on the sensor we use. Also, we can measure the temperature, for example. And some common sensor that used in robotic is like camera, LiDAR, this is in the UAV, and then ultrasonic sensor to measure the distance, encoder to measure the speed or velocity, and then inertial measurement units, IMU. This IMU, we can find it in the UAV. And actuator is the mechanism responsible for the converting control signal into physical movement or action. They act based on the instruction received from the controller. For example, actuator the common actuator in the robot system is a motor, DC motor, servo motor, hydraulic cylinders, or pneumatic valve, for example. And then controller. Controller is the core component of the process sensory information. By using controller, every measurement from the sensor and will be calculated and generated, and then they will be sent to the actuator to be implemented based on what the controller asks. And then there are several typical of the control system in robotic. The first is open loop control. This is the very basics one. We can see from this figure. So we have the reference, and then we have the measure error. However, here the output of the system didn't send to the system so that we can get the error. This open loop control method is very simple. However, it's have an inherent drawbacks. Robustness, they have inherent drawback in robust design. The second method is the closed loop control. This closed loop control we can see here. We have the external disturbance here, and we have system, and we have controller. So from the system, we send a feedback using a sensor, and our sensor measure the output, and then we can find the measurement error. And then based on this result, our controller based on our design, our controller we send, for example, like torque, for example, PWM, for example, or current voltage to the system. And then hybrid control is the combination between these two, open loop controller and then closed loop controller. So several system is highly complicated that we need to combine this together. Because when we force our system to be in closed loop using the closed loop controller, it's very expensive in application, and also very difficult to be implemented in the real system. And also hierarchical control is therefore also for the very complicated system. When we have so many systems with the multiple stars, then we need to adjust our method to maintain the system. Control system, many engineers propose the method in many scenarios to control the system. For example, to control mobile robot, to control UAV, to control robot manipulator, or to control anything, or DC motor, for example. The main objective is how to design a proper and sufficient controller for a robot to become realistic and cheaper in practical implementation. So this is the key. It is realistic and cheaper for practical implementation. Many advanced techniques have been developed by people, engineers. However, this not not realistic to implementation. For example, like when we have the mobile robot or UAV with the small memory, and then lack of the with the not support by sophisticated hardware, and then it is difficult to design a controller, sophisticated controller to maintain the system. So we need to think about this control design should be realistic and cheaper for practical implementation. And at the beginning of the research, many people they linearize the system. In fact, robot manipulator, mobile robot, or UAV are and contain the nonlinear dynamics. At the beginning of the research, many engineers linearize the system and then control the system based on the linearized model. By using this technique, so we can control the system, but only in particular point. We can say that this technique is relatively mature with existing results. And from the very simple controller, for example, like PID, this PID is a very famous one, or MPC, have been proposed to maintain the system. And nowadays, many people, many engineers, especially control engineers, they try to integrate the control theory and the machine learning to maintain the robot movement. Here's our main topic here. What is the research challenge in designing controller? The first is a robot is not always in the class of fully activated system. What the meaning of fully activated system? The number of the states is less than the number of control input. For example, like in UAV, we have the 6 states, and then we only have 4 control input, and then it's difficult to manage. And also the presence of the nonlinear dynamics. It is not ordinary nonlinear dynamics. Sometimes it's highly nonlinear dynamics that we need to maintain our system. And another problem is the presence of the external disturbance. For example, like in UAV, maybe windy, maybe dust, so many wind gas, for example, so many disturbance that we may face in the real application. And the last one is all parameters of the robot are not always available for control design. For example, like in UAV, we have the inertia parameter. Or for example, like when we, like in the aeroplane, for example, the number of passengers may vary one time to another time. And then in this case, it means that the mass is different. If the mass changing, it means inertia parameter also change. And then in this situation, a proper control is required to be designed in more, in better application. What is the prerequisite to design a controller? In simple case, we can say that linear algebra, calculus is mathematics, and then basic programming. So for anyone who understands this tree and then have knowledge of this tree, and then they can design a controller using the control theory and then extend it using the machine learning control. This one simple example. If we consider this state, so normally in the system dynamic, so we present our system in the state space. So this equation is state space. X dot, the meaning of X dot is dx dt. So we have the Wt fxt, and then delta t plus ut. Here xt is the state. Let's say this xt is the position. It means x dot t is the velocity. Wt is Wt is an unknown parameter. So we have an unknown parameter, and then fxt is the known function. And we have the external disturbance here, delta t, and we have control input ut. In case if this parameter wt is a constant, and if disturbance constant, yeah, this not too difficult to design controller. And sometimes the WT available for forward control design, so that we can propose the simple fully feedback linearization. However, in many applications, this parameter not available, WT. This is a very simple equation for the system dynamics. And delta T, the disturbance also not available in for feedback control design. In this case, so we need to design controller to maintain the system. To handle this unknown parameter, there are several techniques that we can handle the system. In control theory, so we can propose like fixed theory or robust control design. We can design the adaptive control, or in the recent control techniques, we can use the machine learning control. So this general objective in control system, the first tracking control to follow the site trajectory, path planning, optimization, state estimation. State estimation is mean that in many cases, for example, our sensor cannot measure our output accurately. It means that there is a gap between the actual state measurement and then the actual state value. And also for the robot navigation. What is the solution under this for this question? For this equation, what's the solution? So there are 4 solutions for this. The first is by design the robust control off-scale controller using the offline estimation. The idea behind this technique is to dominate the unknown parameter or unknown disturbance. The second method is closed-loop parameter identification. For the first method, for the offline estimation, so we can use the offline system definition, for example, like using integral method. And then for the second one, closed-loop parameter identification, so we can use like, for example, like a recursive least square, for example, or we can design any adaptive controller. And then more advanced technique is machine learning control. Even we can say that machine learning control is very robust against the unknown parameter and unknown disturbance. However, this machine learning control, this human product, no technique is perfect. This machine learning control have the one problem, because we can control the system with the residual error. What does mean? Because when we approximate the unknown parameter or unknown disturbance, so we have the gap between the actual value and then our approximator. In this case, we have the residual error that might lead our system to the wrong way. And what the many people did now is to combine between these two, the classical control theory and machine learning. So classical control theory cannot believe. We cannot leave that control theory. So we need to combine it together. And then for the future perspective, this for the future perspective. So we need to design the hybrid controller using a control theory and machine learning. These are our suggestions for the future. So if we see that top journal of the control system and the control design is with like very long mathematical equation, and then it's proof, and then it's difficult to follow. And when we adapt the machine learning to maintain this, handle the problem, and then we can simplify the problem. However, because we lose the asymptotic stability using the machine learning control, so we need to combine it together. For example, like the weight of the neural network can be estimated or can be predicted using the adaptive control design. And then for the some part of the unknown function, we can use neural network, for example. Or another technique that common technique using for maintenance system is fuzzy, for example. So the combination between two techniques is very important. And also the second thing we need to think is realistic in practical implementation. Robot not always have the sophisticated hardware. Yeah, small UAV, they have the small memory, small processor. And when we design our machine learning control, for example, with there's too many hidden layer, and then yeah, that here with heavy computation, this might not applicable. So we need to adjust this. Make sure that our design is realistic in practical implementation. And then the third thing is our robot can handle the multitask. And the last one is one very hot topic in control system is operative control of multi-robot. So in this technique, we can use a classical control technique, and also we can combine it with machine learning. Several results from our research here. So in the first one, so this we give a brief explanation about the control theory, and then cognition, and also some information about sensor, actuator, and then machine learning prospect in control system. And the second two is for the using the control theory. Yeah, thank you very much. I return it to the Dr. Satria.
Yeah, thank you so much, Dr. Emil Hamda, for very interesting presentations. I think many questions rise up. So anyone who would like to have a question, please raise your hand, or you can write it down in the chat box. Yeah, this is the very nice topic about the application of control system in robotic using machine learning and AI application. Yeah, this is the control theory, the machine learning. All right, anyone would like to ask the questions? I think, this appreciation from Dr. Faik Bahrain. We should have appreciation from Dr. Hamda. All right, anyone with questions? I think I will check the chat box first. I think the presentation from Dr. Emil Hamda is very clear enough. So nobody asked the question. I think this is one question from the. Let me read this one. Question. I would most people argue for the use of robotic due to human error. But what about the robotic? Doesn't robotic also rely on human resources to operate them? One question.
I agree with that. Yeah, of course, there's nothing is perfect in the world, even robot and human. So when we do something, and then we may have some shortcoming and mistakes. And in robotic also like that. But what is different is in the robotic, in designing controller of the robot, so we have that, we call it sometimes a global stability, local stability. So we have the several definition. So when we design a controller, and this may not always correct. For example, like error measurement, or maybe for example like extreme disturbance that might cause so many problems in the robotic. However, what we know that in the real application, for example, like in an automotive manufacture, for example, so robot manipulator can install a new engine to the new car precisely. And also, for example, like for the surgery robot, so they can do something that human have limitation to do that. And some robot, they have the autonomous robot and also semi-autonomous robot. For the fully autonomous robots, we don't need a human operator to operate the robot. However, for the semi-autonomous system, so sometimes human is required. Sometimes we can make it autonomous. For example, like in aeroplane, when for the landing and then take off, pilot will handle that, always like that. But when we reach the particular altitude, so the pilot can activate the autonomous the autopilot system, so that the pilot can take a rest, and then but of course pilot should watch the system in case if his help is required. I hope this can answer the question.
Yeah, I think the questions are already answered, clearly stated from the.
May I have one question?
Yeah, sure, Dr. Faik Bahfen.
Thank you very much, Professor Hamdan. The use of medical robotics. How about the informed consent issues in relationship between medical doctors and patients?
This is always a problem, especially for the ethical. Like as electrical engineer or robot engineer, sometimes we didn't understand about the medical ethic in medical field. This is a big problem. So for this we need to have agreement. So sometimes it's not easy to incorporate these two. But I think it's very possible in the future. This is always the problem. For example, like when you want to measure something, and then many doctor reviews that. Of course, doctor worry if we did some mistake because we are not a doctor, and then they have responsibility to the patient. It's always the problem in ethical.
Not only ethical and legal aspect.
Legal aspect as well.
Yes, okay. How about the pharmaceutical services in robotic? Do you have pharmacy services? Not only medical robotic. How about the pharmaceutical robotic?
I read some paper about the drug delivery. It is also one application. In this case, the very accurate control is required. For example, like we cannot have the 1% of fitness. I mean, like 1% error is a big in drug delivery, and then in the it depends on. For example, like for the industrial application, sometimes we have error 2-3%, and then we consider that it's a good result. However, in the surgical robotic, and we have the 1% error, and then we consider that it's a big error. It's very relative.
The robotic in pharmaceutical industry only also applied of GMP, good manufacturing practice.
Actually, I don't know about that. I'm not sure about that. Because for my research field is about the UAV, robot manipulator industry.
Okay, thank you very much. Masalam.
Thank you. There is someone raise hand, Miss Aisha. You can directly ask Professor Emil Hamda.
Thank you so much for your chance, and thank you so much for the speaker, Mr. Hamda, for the great presentations. Actually, I want to ask about the questions about the deep learning, right? Because there is the self-automation, which is used by the deep learning for the self-driving cars, or for the example, right? What are the significance of the basic principle, difference between the combining about the sensor system with the machine learning and the self-automations by this itself, by the deep learning for the automation, self-automation? I think I haven't get the significance of the difference about them.
Sorry, I couldn't hear your voice clearly. Could you please?
Can you hear me now?
Yeah, it's clear now.
As far as I know, there is the self-automation, which is used by a deep learning algorithm, right? The self-automations, which is used like the robotic And my questions, what are difference the principle between the working of the control system combining with the robotic and the self-automations by deep learning algorithm, like the self-driving? Are the principle different between both of them?
Yeah, for example, like this in a control system, let's say we design a controller using adaptive control or using the robust control, learning mode control, for example. The information we need is when we have the output, we measure the output of the system, and then our sensor we send it to and then when we compare that with our reference, let's say I have a robot, so I have this head trajectory, and then for the actual trajectory and the set trajectory, I have a gap error between them. So from that result, so I will generate my controller. In nonlinear control, so we can consider system as nonlinear, and then we design controller using that nonlinear system, and then we can send that, let's say that desired torque for the robot, so that they can move to the desired path using machine learning. I mean like pure machine learning without control design. So we have the output for the system, and then we compare that for our reference trajectory, and we have error. And then, for example, when we use neural network, for example, so we 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 have this several steps. For example, like we use the Gaussian, and then we use like we linearize the system. Our system here using the machine learning not exactly control the dynamical of the system, but based on the error measurement. I mean the measurement and the actual system. For example, like if I have if my reset trajectory now is 5, position 5.5, for example, and then my actual system is 5.2, so I have the error between that. From that, and then they will send the new instruction to the system to give more torque, for example. And after that, they will adjust again. So if the error increase or decrease, they will evaluate the system based on that. However, in control system, not like that. The system is they will keep the system in nonlinear dynamics. They will design based on mathematical problems. So we prove that mathematically. The difference is in machine learning, it will be faster. And also, they have some weakness. This is a residual error because of that. Because they didn't control the system exactly. Because they didn't care about the system dynamic of the system. It's a big problem. However, even like that, if we control the system using nonlinear controller, we also have problem there. Sometimes our control design is very complicated, and then we have so many time derivative, so many integrator, for example, that this not possible. I mean, like this not realistic for the practical implementation. In this case, so machine learning control is better than control design. However, in simulation, maybe control theory is better than machine learning. So there are several factors we need to consider. Depend on our hardware. Do we have that sophisticated hardware or not? Or we just have small hardware? So we need to consider that.
Yeah, thank you.
Thank you so much. So I think I can conclude, if you wanna implement the control between machine learning or the machine learning, it depends on the necessity which you wanna use it, right?
Yeah.
Thank you so much.
Yeah, thank you, Mr. Aisha and Dr. Emil Hamda for the questions and answers. Now we come up with the last speaker. Before the last speaker, we would like to give some certificate to the Dr. Emil Hamda. Maybe Ms. Intan could and Dr. I think our Professor Jaswar or Professor Laude is joining with us to give the certificate. I think Dr. Professor Jaswar is already here.
Yeah.
All right. Intan, could you please show the certificate. Yeah. Yeah. Hello, Prof. Jaswar.
Yeah, okay.
Yeah.
I think the frame should be changed. Maybe Dr. Hilmi. Okay. Bismillahirrahmanirrahim. Thanks, Dr. Hilmi, for you today UICI webinar. On behalf of UICI and Rector of UICI Universitas Sains Kita Indonesia, Professor Dr. Masih Kamaluddin, I give a certificate for you. Thank you for you.
Thank you very much, Dr. Joshua. Yeah, really appreciate it. Jazakallah khairan.
Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum.
Thank you.
All right. Thank you so much. I highly appreciate for your sharing and for your time and joining with us. The next session, the last session is I would like to Professor Shafi'i Shamaun. Before he give talk, I would like to introduce by showing his CV. Yeah, this is his CV. Let me all right. This is Professor Shafi'i Shamaun. Currently, he is the associate professor in the King Abdulaziz University, and then he also tenure lecturer in the University of Putra Malaysia, UPM Serdang, and he did the postdoctoral fellow or researcher in University of Valladolid, Spain, and also he did the postdoc researcher in University of Ghent, Belgium, and also did the postdoctoral researcher in the University of Valladolid, 2007-2008, and publications. Yeah, yes, very active in terms of the publications. If you see here, his publication is too much. Yeah, he's one of the highly cited professor in the King Abdulaziz University. Yeah, he has some book chapter, and also he actively in the international conference. You can see here of his career. Yeah, he also granted for some funded research from the various agency. Yeah, also he invited lecture from all around the world. Yeah. Also, this is all right. We give the talk to the Professor Shafi'i. The time is yours. Thank you. I think you are still unmute.
Assalamualaikum warahmatullahi wabarakatuh. Hamdan syukralillah, salaman wa salama ala rasulillah. Okay, it is we speak in English, not in Bahasa, right? Yeah. Okay,
Yes,
thank you
correct,
so
correct.
much. I would like to try to explain something about facing artificial intelligence era. Why we call this artificial intelligence era nowadays after some researcher in the Western country introduced to us machine learning or another type of artificial intelligence. And also the thanks to Jeffrey Hinton, who developed deep learning, nowadays the artificial intelligence is booming, especially after the ChatGPT is announcing and also brought an other competitor in terms of natural processing language. So I would like to go with this title, how to face artificial intelligence era, how to be ready in this case. And I would like to give some example for that. And from the briefing, what Satria already mentioned to me that I did my PhD on machine learning, especially on reinforcement learning with application to chemical processes. And then I switched to model-based applications such as time delay system, and also on positive system and so on in that field. And okay, let's see, for today's talks, we want to go to this objective, especially, and four of this objective is to brief on artificial intelligence. What is artificial intelligence? Why artificial intelligence is very popular? And I will give some example on learning by doing, how to learn from what we do, and also to show a pattern recognize, how we can recognize a pattern. And I will give some tips on how
Go ahead, Doctor.
us is, what is artificial intelligence so popular? Yeah, nowadays, everything we talk about the artificial intelligence. This very popular because now artificial intelligence can come to almost all field of science, in not only in exact science, but it's also go to social science on application of this artificial intelligence. That's why the artificial intelligence is very popular. And why it's so very popular lately? Because this is the artificial intelligence is ability of a computer programming to perform tasks such that the deal with the giving machine ability to seem like they have human intelligence. So the machine have the human intelligence. How the machine have the human intelligence is of course from the algorithm that we develop and introduce to the machine. Okay, so from this, why the artificial intelligence is so popular, because it also applied in so many areas and very easy in mathematical interpretation. Before, our speaker already mentioned that from the control theory in terms of the mathematical applied is very difficult. And I will give a little bit introduction later on the mapping of mathematical application in all field in science. Okay, the branch of artificial intelligence is, for example, come with the logical artificial intelligence, and then for the search, that coming with the search engine, and then for pattern recognize, I will go later on and see how we can use the pattern, and then to representation, inference, common sense knowledge and reasoning, learning from experience, planning, epistemology, ontology, heuristic, and genetic programming. Maybe some other type of branches is not mentioned here, but this is according to what our group in Stanford University provide these branches of artificial intelligence. And the application in so many areas, and we can classify them in terms of four: in signal processing, and then in expert system, agents, and also in learning system. So that's why this artificial intelligence is very popular. Now, I would like to introduce a little bit for learning from the interaction. So learning from interaction, especially we go with, we call reinforcement learning. Reinforcement learning is popularized or introduced by Richard Sutton. This is the picture of him on the right side. So he's introduced this reinforcement learning together with Barto, and his idea is taking an action and then after applying to the environment, from that one, we give the reward to the action. Either the action is good or bad. Then the agent will provide another action and implement to the environment. And from this cycle, from this loop, the agent will learn from the given action, from the provide the action, either good or bad. Then from that interaction, the optimal solution will be provided later on by the interaction. So reinforcement learning is based on this interaction. It is a problem that involves learning what to do. For example, how to map situation, what we call state in another area, other branch of control, to the action, so as to maximize a numerical reward signal. So usually in most of application, we try to minimize the error, but in reinforcement learning, we try to maximize the reward. This is such different. Maybe we are facing this problem and very used to play with this tic-tac-toe or kali silang in bahasa. We used to play this when we were in school or in senior high school, in junior high school, maybe we used to play this. And from this playing, we can try to learn how to develop such a mathematical algorithm from here, or mathematical formula, such that the value of taking the action can be estimated as this kind of the value. This means that when the opponent move, then we try to move our move on. All of these paths we can develop in terms of this value function in reinforcement learning. Then from that value function later on, the agent will learn how to maximize reward for each action is taken. So reinforcement learning is the value base to maximize a value function expecting a long-term return or reward of the current state under any policy we apply to or we take to. Can we call this as a pie? And then a policy that action performed in every state, or I call it before a situation, to gain maximum reward in the future. Either the policy can be deterministic or stochastic, depend on what the problem we face. And we can also apply on a model-based reinforcement learning that the agent will learn to perform tasks in a given specific environment. And nowadays, the reinforcement learning is very popular in the world because ChatGPT developed based on this reinforcement learning algorithm. And the characteristic of reinforcement learning, such as there is no supervisor, only a real number or a reward signal. Based on that reward signal, the agent will learn and can provide the sequential decision making. And time play a crucial role in reinforcement learning. The more we interact, the more optimal of the decision will be. So it's keep interaction with the environment, and the agent will be more optimal and more robust. Feedback is always delayed, so no instantaneous feedback. It is always delayed in this action. The feedback means the action we take now will come as the reward after we do the evaluation to the action itself. Agent action determine the subsequent data after each receive. That's why we have the reward. We have a positive reinforcement learning and negative reinforcement learning. So positive reinforcement learning occur because of the specific behavior. It is to increase the strength and frequency of behavior and impact positively on the action. while the negative reinforcement learning will impact negative condition which should have stopped or avoided. So this is the type of reinforcement learning. And it is based on Markov decision process. And I think everyone know about what is Markov decision process. It's a mathematical approach for mapping a solution in reinforcement learning to recon as a Markov decision process. And the most popular algorithm in reinforcement learning is Q-learning, is a value-based method of supplying information to inform which action an agent should take, which action should take. So from this Q-learning, the formula is very simple. We can get so any learning rate for the alpha, and gamma is the discount factor of each Q value which should update in each iteration. So from that, now I would like to go for the example. So I developed one example for this article. We call learning control for bad thermal sterilization of canned food. I think everyone now the canned food. What is canned food? So we have food inside the can, and before come to the market, we have to sterilize it, and that is we use thermal sterilizer. The problem in the thermal sterilizer is that when we heat the cans, the temperature inside the can is also increasing, and together the pressure is also increasing. After several times, after lethality time is reached, then we must cool down the food quickly. While we cool down the food quickly, the problem is to the pressure. We cannot quickly decrease the pressure inside the retort. That's why we have to keep the pressure gradually to reduce. So this one happened in the batch sterilization process. So we have water here is to cool down, and we have the air here we introduce is to keep the pressure inside the return, and also we introduce steam to heat the can. And from that, we can maintain the temperature and also the pressure inside the retort. So this is the sterilization problem. And we use these what we call model-free learning control based on the reinforcement learning. We slightly modified what the Sutton and Barto provided on interaction reinforcement learning. And then from this, we can develop the controller based on this critic. So we call this as model-free learning control from this loop, and then we have the set point and also the output from the plant. And this is all the controller, and we can see later on how we can calculate. So now we have these horizon. Such horizon is where the state of the controller will have, and also we have the goal state. Goal state means where the reference we want to end up the system in. So from this, state definition, we try to develop the amount of action available in that stage. And from there, we can develop the action like this. And from here, we can then see the action state definition. We call the span of, and each state can be calculated as this span between F and D, and divided by H, how far is the span itself. And then we can develop the positive bound parameter to represent this number. Okay, and then from this, we can represent the symbolic states by using this equation. And then from there, we try to find out the symbolic current state by having the argument maximum of G state. And from that, we can develop the control signal as the PI control signal. Okay, proportional integral control signal. It is we update the integral, the control signal previously by again, and the difference between this action, the weighted action and the taken action. From this, then we can calculate what is our U, our control signal. And then we define how many states in each state, the total state will be like this. And from this, we can have the reference action, we call weighted action as the middle of the state. Then we can implement this logic of learning logic for this case, for the heating state, and also for the venting state, and also for the heating state, and also for the cooling state. So then we develop this parameter, or we choose this heating up controller parameter based on this reward. So we define this reward is 1 if the error is going to be less, and we define the reward is -1 if the error is not going to be less in each action. So then this is the parameter. We call all this parameter we define. This is such as a tuning parameter we can do later on. And after that, we apply this simulation, or we train our agent from the modeling. We train this our agent, and we found that our agent is going to be better. From this, you can see it going to be better. And this is the time response for the pressure, and then is the temperature. The temperature must suddenly drop, and we try to reduce the pressure gradually. So our set point is changing here for the pressure. And this is the valve position, for this sample. And also we try for this change of the temperature. And this is also the control signal look like. And this is the online application, real application in the retort, in the lab experiment. We found that the response is look like this. Okay, we have red color and the blue color here, a red color and the blue color, and yellow, green color is as a set point, while the black color is now we define as a goal state. So we try to bring our response to be inside the reference. And from here, we can see that the blue one is the nominal response, and the red one is the optimal response. The actual response. And I will show you one example on pattern recognized. For example, on pattern recognized, if we have binary data set or classification, we have the data of xi and yi, where I itself is n data set, and we have yi is in between -1 and 1. Okay. Then we can have the hyperplane. In terms, this is a linear hyperplane, and from that we can have separation of the hyperplane to be either in +1 or in -1, or we can call another, either this being above hyperplane or lower hyperplane. Then if we combine these both, we will have this type of combined hyperplane. From that one is we try to minimize this weighted of the hyperplane, and from this weighted hyperplane we can try to minimize this with constraint of that hyperplane itself. And then from this we apply the Lagrange multiplier. From this Lagrange formulation we can make it up our constraint to the objective function. From that objective function, now we can take the derivative of this to omega, to w to the wake, and while we take the derivative to the wake equal to 0, that means we try to find out what is wake, and we can also do to find out unknown beta here, unknown b here, and from this we can take also the derivative to b to get b itself. And then after algebraic manipulation, such that we have this is our Lagrange, and then from there we can try mean that we applied finding the unknown hyperplane. And many problems we face when we have this type of hyperplane, on especially on this type of operation. For this type of operation, then we can use what we call a kernel. And from that kernel mean that is we try to portray our or also we can call to transfer our input space to another space, for example, to the feature space, such that we can have more simple hyperplane to do the separation. So this idea is implemented for the carpet classification. For example, in carpet classification, usually this is done in when I was in Belgium. So we have the carpet, this carpet 1, and this carpet 1, we try to classify belong to which class of this standard class. Okay, usually from the human behavior, from human doing, this will go with the label, such as go with this label. This is by human visualization of the carpet classification. Now we try to do this human activity by the machine activity. That machine activity, for example, we try to get that carpet and we do the 3D scanner. We have this scanner of the carpet with the surface and so on. Then from that, we try to get a dimension and feature. And then from this feature extraction, we try to do the computer model. And then from this computer model, we go with computer labeling. And computer labeling will also provide us the label of this carpet. So from this application, for example, while we use a support vector machine as our classification. And here we found that this is the support vector. The one with bracket sign is the support vector from there. And from this one, we develop the hyperplane. And this is also for another type of the carpet. And from there, we see that the carpet presentation, this is type of the carpet. And then we use polynomial kernel and Gaussian kernel. We see that Gaussian kernel can give us more percentage of classification than the polynomial kernel. So that's what we use for classification or pattern recognize. And before I go with the tip for education facing in artificial intelligence era, so machine learning, in fact, is only two types. It is regression or classification. Okay? It is only two types. Either to do regression, then from that regression, you can do the prediction, you can do some type of analysis, and also for classification. Okay, and I would like to go for the types of facing era on artificial intelligence. So artificial intelligence is nothing more than the evolution of this industry since the steam engine was discovered, and then from that to the man work is replacing by the machine starting in 1782 in European country, especially in Western European, and then goes to application of mass production in 1913, especially in automotive industry. And then after World War II, the computer was discovered. And then after discovering the computer, now the industrial revolution is very rapidly grows to cyber physical system. And nowadays goes with artificial intelligence. And I would like to call that now in last 5 years, we can say, or maybe last 10 years, people talk about data, and big data analysis is more important nowadays. And big data analysis or this kind of data is always goes with artificial intelligence. So nowadays, the data growth is very exponential, and most data is unstructured data. Most data unstructured, it is in metadata, okay, not in that type of structured data. And it is grows exponentially. And we have to find this data, we have to deal with this data, and this data will give us so much information and so much also money in handling this data. So I would like to call about this AI resonance, the computer processor discovered, and the speed of the processor nowadays is also very fast. And we can have the big data, the large amount of unstructured and structured data to be processed, and rapid growth in recent decades of the computer approach. Many application or computational approach or methodology and so on come up very rapidly in recent decades. So I would like to talk a little bit on data. The data first, for example, is saying by this economist that now the world's most valuable resource is no longer oil, but data. If you see nowadays, each company in the world is dominated by data companies such Google, Amazon, Microsoft, Apple, Uber, and Tesla, maybe Facebook and Meta and so on. So that's what happened nowadays. Everyone is talking about data. And in Indonesia also, maybe you know this Otto, Mr. Otto, the one who's very rich in Indonesia, is also from a data center. He's also dealing with the data and he's very rich man now. So in the integrated transistor, what I mean by this one, now the processor is very fast, so we can use this. Okay, and AI in education. Nowadays, I would like to speed up the speech because the time is not enough. So in education also, AI is now evolution so much, especially after the, after this what we call COVID-19, the education in AI is rapidly grows, and many things also now is going to talk about the AI. So how to be ready in AI? First, we have to learn or we have to master the language. Okay, especially English language, because English language nowadays is the science language. And come with Spanish language. Why I call Spanish language? Because in Latin speaking countries, they are having their own community and written their science in Spanish. Also, most of Russia, we have to understand Russian language also if we can, because Russia is not published so much their works in English. They are publishing in Russia. And Russia technology nowadays in artificial intelligence is very strong, especially in cryptocurrency. And coming China, and we have to learn Chinese also because Chinese now have their own community on science and written in Chinese. Okay, and also we have to learn a little bit about how to do coding, understand code such as Python maybe, or another type like JavaScript or something else like this. So this is how to be ready in artificial intelligence. We have to learn the language, and then also we have to reach more. So beside that, we cannot avoid these our what we call our basic in mathematics, that mathematics play all the role in artificial intelligence, and most of the paper in artificial intelligence, most of algorithm in artificial intelligence, and also most of technology in artificial intelligence was not written in terms of mathematical language, but written in terms of the explanation. But behind this technology is all mathematical language. It's all mathematical language. So we have to understand the basic language of this mathematics, especially if we want to go in deep, we have to understand linear algebra.
Yeah.
Linear
algebra. I'm sorry, Doctor.
Yes.
You can come up with the conclusion at the time. Is that?
Yes. The next
Yeah,
slide is the conclusion. Yes. Next
right.
slide is the conclusion. Okay. And we have to go with this linear algebra. Okay. I would like to conclude that we have to do our reading more, especially we read in the name of the Lord who have created. Mean that we have to read more, and then we have to write more and more. We have to write, we use the pen. This is my conclusion. We have to read more and to write more. Thank you so much. So I will give it back to Dr. Satria for
yeah, thank you. Very outstanding presentations from the Dr. Shafi'i Shamaun, from the talk about the facing in AI era. As we listen all together, maybe you have some questions, please don't hesitate to raise your hand, or you can write it down in the chat box. And I will check questions. Yeah, there is one question. Will artificial intelligence make society more prosperous and relaxed as AI can replace human job? Yeah. Or is it the what he said? Yeah.
Yeah.
You got the questions?
Great. Yes, I read the question. So it's a question from Mr. Komang. Yes. Will artificial intelligence make society more prosperous and relaxed? So artificial intelligence is also human match machines. So nothing can replace human by machine. Okay, machine can replace human. But somehow the artificial intelligence is to help human on their working, not to replace, to help human on their working. So cannot say to replace, but some job will be, replacing by artificial intelligence. What I mean, some job is not to say 100% replacing, but minimizing the opportunity for human to be in the artificial intelligence. Example nowadays, if we can see how the interaction in between user and provider of the technology by simple interaction on human-machine interface, then from that human-machine interface, the AI applied to that problem, and from the AI you can get the solution. Example, silly. If nowadays you want to get help on how to write application letter, a job application letter, example, you can just type on the human-machine interface on, for example, ChatGPT. From that one, you can get the answer. But that answer, you must also retune it, read it, and maybe retune it. You agree with the machine or not agree. So that's example on the social application, how the artificial intelligence is now being applied, and for so many also. Nowadays, in some countries, like in the Western countries, and also some Asian countries, they try to implement the law by helping practitioner of law, like a lawyer, by using artificial intelligence. Nowadays, if you have a case and many law or act related to law can suggest by artificial intelligence. I think this is how it will be. And potential lead to explosion due to metadata or cloud storage. Same thing happen nowadays. The cloud storage or data is in other words, is the space of memory that's provider provide. Due to the development technology in nano material, from this nanotechnology, the data space is going to be stored huge data in a single disk now. This is also that technology is not stopped. So the nanotechnology and also data technology is not stopped. So that this will be the growing of this one. Okay, thank you so much. I thought I can answer Mr. Komang's question. Thank you.
Yeah, thank you so much, Dr. Shafi'i, to answer the questions. I think the time, I think it's more question, but actually the time is over. So we will close this session actually by giving the certificate, I mean, from the Professor Jaswa, or I think our rector, Professor Laude, still, I think, with us. Hello, Professor. Could you give a conclusion remark or close this session? I think he is away. All right. I think on behalf of Professor Laude, we'll ask the Professor Jaswar to make a conclusion remark and give some certificate to the Professor Shafi. Tafadhol. Yeah, Prof. Jaswar. Yeah, Prof. Jaswar, are you with us?
Yep. Yeah.
Yes, Intan, you could you please show the certificate?
Okay. Maybe Dr. Sabi. Okay.
Thank you so much.
Thank you so much. Bismillahirrahmanirrahim. On behalf of the University Insan Cita Indonesia, Rector, Professor Dr. Laude Masih Kamaluddin, I'd like to give the honorable certificate for the honorable speaker, Professor Safi Samaun.
Yeah.
Okay, thank you so much.
Hey.
Thank you so much. Thank you so
Thank
much.
you. Again, applause. Yeah. It's very, thank you so much to the all speaker who joined with us and share the knowledge to our students, also from our colleagues from the University of Insan Cita Indonesia, Jakarta. Once again, I hope this is very useful for the future. I mean, the role of AI, machine learning, as the speaker mentions early. So I'm the moderator. Sorry if I had mistake. So let me back to the MC, Mr. Aisha. Thank you so much once again to the all speaker. And also if the rector has with us, maybe give some conclusion remark. Otherwise, Mr. Aisha can give to the Aisha. You can call the Prof. Laude. Thank you so much.
Yeah, thank you so much for your leading, Mr. Satria, and thank you so much for all the speakers who have given the great presentations, and we got the much new insights about the implementation of AI in our life, right? And thank you so much for all the participants who have joined and stay until the finish. I so much appreciate about your attendance. And before closing, we will have the photo sessions. Please, Intan, help me to take the photo.
Okay.
I think there are 3. How many screens we have? It? Many screens.
Yes.
Okay.
1, 2, 3. Again. 1, 2, 3. Okay, Mbak.
Okay, done?
Done.
Done.
Then okay, thank you so much for Intan to help take the photo sessions. And we are so sorry as the organizer if we have many mistakes during this event, and I hope this will be beneficial for your life in the future. And thank you so much for attending this event, and we will see again for the next event. Bye. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum.
Penerimaan mahasiswa baru tahun ajaran 2023-2024. Berikut adalah penjelasan singkat kenapa kamu harus kuliah di UICI. Strong Network. Kelahiran UICI diumumkan langsung oleh Presiden Republik Indonesia Joko Widodo, serta didukung oleh akademisi lebih dari 3.000 guru besar dan doktor, pebisnis, profesional, pejabat publik, dan alumni HMI. Inovatif. UICI mengembangkan Artificial Intelligence Digital Simulator Teaching Learning System atau AI DSTLS. Sebuah sistem perkuliahan berbasis digital yang memungkinkan mahasiswa kuliah di mana saja dan kapan saja. Fast growing. Hanya dalam waktu 4 semester pertama, mahasiswa UICI telah tersebar di 34 provinsi, 420 kabupaten dan kota di Indonesia. Beberapa mahasiswa UICI bahkan berdomisili di Inggris, Cina, Arab Saudi, Turki, dan Jerman. Sebagai kampus yang inovatif, UICI hadir dalam berbagai program studi unggulan. Yuk kenal lebih jauh. Yang pertama, ada komunikasi digital. Prospek karir di program studi ini, kalian bisa menjadi digital public relation dan marketer, jurnalis, desain grafis, fotografer dan videografer, peneliti komunikasi digital, dan sebagainya. Bisnis digital. Kamu juga bisa menjadi peneliti teknologi bisnis digital, analisis bisnis digital, spesialis pemasaran digital, konsultan bisnis digital, teknopreneur, dan sebagainya. Untuk itu, program studi bisnis digital menarik sekali bukan untuk dipilih? Informatika juga hadir buat kalian yang bercita-cita menjadi programmer, seperti mobile app developer, artificial intelligence engineer, network engineer, UI UX designer, database administrator, sistem analis, dan sebagainya. Kemudian ada program studi Sains Data, sebagai prodi yang katanya sebagai program studi paling seksi di dunia digital. Kamu bisa menjadi data engineer, data visualization engineer, machine learning, dan sebagainya. Digital Neuropsikologi, Prospek karir di program studi ini, kalian bisa menjadi praktisi psikologi dan terapis, praktisi pengembangan sumber daya manusia, peneliti neuropsikologi, psikolog bila melanjutkan pasca sarjana, dan sebagainya. Teknik industri. Prospek karir di program studi ini, kalian bisa menjadi engineering supervisor, engineering consultant, professional engineer, designer engineer, project engineer, teknopreneur, dan sebagainya. Teknologi industri pertanian. Dengan pembelajaran yang khusus, di prodi ini kamu bisa menjadi agro-teknopreneur, agro-engineering supervisor, agro-engineering consultant, agro-design engineer, agro-project engineer, agro-manufacturer industry, dan sebagainya loh. Dengan teknologi dan inovasi yang dimiliki UICI, kamu juga harus tahu apa aja sih keuntungan yang didapatkan di UICI. Yuk simak. Yang pertama, kuliah dapat dilakukan kapan saja dan di mana saja. 2. Kuliah dapat dilakukan sambil bekerja, berbisnis, traveling, dan aktivitas lainnya. Yang ketiga, kuliah dapat diikuti oleh siapa saja lulusan SLTA sederajat yang memiliki nomor induk siswa nasional atau NISN. 4. Dapat kuliah di 2 tempat sekaligus sehingga bisa mendapatkan double degree. Terakhir, pendidikan berkualitas tinggi dengan biaya yang sangat terjangkau. Jika sudah memahami, masih ragu apa lagi? Ayo silakan daftar, gabung, dan tumbuh bersama UICI. Informasi bisa kalian dapatkan di www.uici.ac.id atau pendaftaran di link pmb.uici.ac.id.